Guys, and welcome back. So this video is to help you with day 2 of solving by substitution. So the difference between day 1 and day 2 is that now instead of having one of our equations already solved for us, we are going to have to solve one of our equations. And so the steps to solving will still be the same. We just want to make sure that we're going to have to actually do this first step here where we're going to have to solve one of our equations for x or y. Then we can do our substituting, our solving, resubstitute, and write our final answer as a point. So we're actually going to start down here at number 5. So what your goal is to look and find a variable that doesn't have a number or a coefficient attached to it. Because if we were to have to solve with a number on it, we may end up having to divide and get fractions. And while we could still complete the problem with that, we like to work in an easier manner. So I noticed that in the top equation, this y has a coefficient of positive 1. And that is music to my ears because then I can say negative 5x plus y is equal to negative 2. I can then just solve for y by adding 5x to both sides. And then seeing that I have y equals 5x minus 2. Now my y is by itself and I'm ready to substitute. And all it took was one little step. So I can take my 5x minus 2 and I'm going to plug it into y in my second equation. You want to ignore the first equation because we solved that. So we don't want to plug back into the equation that we solved. So I'm going to have negative 3x plus 6 times 5x minus 2 equal to negative 12. Then, just like before, I'm going to distribute my positive 6 into both, get negative 3x plus 30x minus 12 equal to negative 12. I can then combine my like terms, which is the negative 3x and the 30x, and that'll give me 27x minus 12 equal to negative 12. Then I want to get my x by itself, so I'll add 12 to both sides, giving me 27x is equal to 0. Now, a lot of students at this point think, oh, well, it's 0, so there's no solution. 0 is a number. Don't discriminate against 0. Our last step is to divide by 27. So we just get that x is equal to 0. All this means is that our intersection point is going to be the y-intercept because the y-intercept has an x value of 0. Then, just like we did yesterday, we're going to take that 0, plug it in for x, and get our y. So 5 times 0 minus 2 will give us 0 minus 2, which is negative 2. So my final answer is just going to be 0, negative 2. And this is a consistent system because they're intersecting. And we know that because we have 1 point for our answer. Now let's look at number 6. Now when I look at my variables, I see that the x is the best one to solve for because it's got a positive 1 for its coefficient. So I'm just going to come over to the side and I'm going to solve for x. So I want to move my 2y to the other side. So that gives me that x is equal to 2y plus 11. So I'm just doing the opposite operation to move the y away from the x so that I get an x equals. Then, just like before, I'm going to take that 2y plus 11 and I'm going to plug it in, but this time I'm plugging it in for x in the first equation. This is the equation I solved, so I don't want to focus on that. So I'm going to have negative 7 times 2y plus 11 minus 2y equals to negative 13. Then I distribute my negative 7 into the parentheses and get negative 14y minus 77 minus 2y equals negative 13. I can then combine my like terms, so negative 14 and negative 2y makes negative 16y minus 77 equals to negative 13. Adding 77 to both sides gives me negative 16y is equal to 64. And then finally dividing by negative 16, y is equal to 4. Once I have that answer, I can plug in, just like before, to my solved equation. So I'm going to have x is equal to 2 times 4 plus 11. So x is equal to 8 plus 11. So x is equal to 9. So my answer is 9, 4. Remember to always put your x value first because it is an ordered pair. So you want to make sure that you have your single answer in the correct order. Jumping up to number 2, we see that the y in the second equation is a positive 1 coefficient, or has a positive 1 coefficient. So we're going to solve the bottom equation for y before we substitute. Solving for y means that we're going to add x to both sides, giving us that y is equal to x plus 3. You could have easily solved for negative x. Negative 1 is your second best option. If you don't have a positive 1 coefficient, but you have a negative 1, go for it because it's just as easy. Dividing by a negative 1 at the end will only change signs. It won't change your numbers. So once again, we have it solved for y, so we're going to plug in for y in the top equation. So we have negative 3x plus 3 times x plus 3 equal to 4. Remember, at this step, we should be left with only one variable. Distributing our positive 3 into the parentheses, we get negative 3x plus 3x plus 9 equal to 4. When I combine my like terms, I see that I have negative 3x and positive 3x. That makes 0x, which means they go away, leaving me with 9 equal to 4. Now, since my variable went away, I'm left with this statement of 9 equaling 4, which I know is false. 9 doesn't equal to 4. Since that's not a true statement, then I know that I have no solutions for this system. That means no number that I plug in will make both of my equations true. And that is remember, inconsistent system because they're parallel lines. The last one I want to look at is number 3. Just like before, we have an x that has a positive 1 coefficient. So that is the equation I'm going to choose to solve. So I'm going to get my x by itself, I will subtract the 2y from both sides, giving me that x is equal to negative 2y plus 4. I will now substitute into the bottom equation for x, because the top one is what I solved. So I'm going to have 3 times negative 2y plus 4 plus 6y equal to 12. I will complete my distribution of the 3 inside by multiplying. So I get negative 6y plus 12 plus 6y equal to 12. Then I will combine my like terms. So negative 6y plus 6y. That gives me 0y. So I'm left with 12 equal to 12. Again, my variable canceled out. So I'm left with 12 equals 12. Since this is a true statement, then I know that I have infinite solutions. And that is a dependent system because there will be the same line. I hope that these examples helped. And if you have any more questions, please feel free to reach out. Have a wonderful rest of your day.